Hi, my name is Bianca Lopez Parnetti, and this is my presentation on Lab 1 charge tapes. So the purpose of this lab was to create a physical experiment with two pieces of electrically charged tapes and observe how they interact with each other, and then create a computational model depicting that entire experiment, and also to calculate the excess amount of charge on a piece of tape and all the related forces and electric fields acting in the experiment. So the main physics principles used in this lab relate to forces and equilibrium and also electric fields. So first we looked at gravitational and electric forces present during the experiment and how they cancel out, specifically in the y direction, leading to a stable net force of 0. And to solve for that electric force that we're looking at in the system, we use an external electric field from all the surroundings and calculate and then use it. So the relevant equations for this experiment were relating to the electric forces and electric field, as shown below. So as a preview of the main lab results, we can see that the first part, the charge on each tape, was 1.17 e to the negative 8 coulombs, and the number of electrons lost by each tape when they were charged was 7.30 e to the 10 electrons. And to create the system and the surroundings in this lab, first we have the system, which is tape B, the one on top, that is expected to move and repel, and the surroundings is tape A and also everything else, but we're really only looking at the influence of tape A, which is the one that we're holding up. So next is the initial conditions for the experiment, and then later that's going to be used for the computational model. So we have the mass of the tape, the length of the tape, the width, and then the area, and also the measured distance between the tapes, and also the length of an atom, which is not just a given. So here we have a really poorly demonstrated creation of the observed model. This did not work. We had to redo it afterwards. But essentially the steps was to get two pieces of charged tape and then float one on top of the other, and then measure the distance between the two tapes at which they begin to repel. And so next we can finally create the computational model, which is going to include all our calculations for this experiment. So first, in the first section, we have the initial conditions and the constants, which set up all the calculations for it. So first we need to solve for the gravitational force, and then we get a value of that, and then we set that value equal to the value of the electric force, because they're supposed to cancel out in order to create that repulsion, And so then we solve for the charge on the tape, we solve for the number of atoms on the tape, and then the ratio of the electrons to atoms on the tape. And then finally, we solve for electric field on tape B due to A, and this is what it spits out at us. So here you have, in the little caption, we have all the printed values. You have the number of electrons on the piece of tape, which is 7.30 e to the 10. You have the number of atoms on the tape, which is 4e to the 17. You have the ratio of them, and then the electric field and the electric force. So some similarities between the data and the model predictions is that the electric and gravitational forces both point in opposite directions to try to counterbalance each other, and also that tape B lost electrons once it became charged, so giving it a net positive charge. But the main difference was that the magnitude of the calculated electric force was higher than the gravitational force, even though they're supposed to be the same magnitude, so there was some error. And some possible sources of error from this were the assumptions of many perfect conditions. So first, that the strands of tapes were treated as point charges instead of actual pieces of tape. They're treated as point charges with a concentrated charge. And then second, that both tapes had exactly the same amount of charge on them with the same equal distribution along it, which is obviously not really going to happen in a real world. So finally, for the additional questions. So the first one is, what if electrons had a positive charge and protons had a negative charge? What would that change about the observations you made with your tapes and other charged objects? So I said that there would be no change in their interactions since both charged pieces of tape would still repel each other due to now having, they still have the same charge but just in the opposite direction, so they would still repel. And so the tape that's now a negative would be oppositely charged from a plastic pen, which is now positive, so they would still attract. So all the interactions would still be the same, it'd just be flipped. But that doesn't really matter with how they attract or repel or whatever. And then secondly, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? So I said that once the charged tapes come into contact with anything else, the charge on the tape flow through whatever is in contact with it because they want to discharge and become have a net neutral charge. So it's necessary to reduce the contact in order to preserve the charge on the tapes and do the experiment. And that is all. Thank you so much for listening.